Hello everybody, welcome to another video lesson. Today we're going over logarithms, a very important and probably new topic for a lot of you. So by the end of today, we'll be able to evaluate logarithmic expressions and we'll know what logarithms are. So let's hop right into it. Okay, so logarithms are essentially just a different way of looking at our exponential functions, okay? And they're really the inverse of our exponential functions, which is why we're going over them in this chapter, okay? So for example, if I have this equation right here, 2 raised to the 4th power is equal to 16, okay? What do all of these different colored elements mean? Well, my 2 is my base, right? 2 is the base. 4 would be my exponent, power, or index. Okay, these are all the same way, they're different words for the same thing, right? These are, you might think of this as exponent, power, or index, okay? And then 16 is my end result, right? That's what I get after I raise 2 to the 4th power. But what does raising 2 to the 4th power really mean? Well, it means I've got this repetition 4 times of multiplying 2 together, right? So I multiply 2 by 2 by 2 by 2, okay? And then I would get 16 as my result, okay? And then a couple other examples. So if I have 2 raised to the 0 power, well, we know anything raised to the 0 power equals 1, right? So 2 raised to the power of 0 equals 1. And then if I have 3 to the 3rd power, okay, that's 3 times 3 times 3, that's going to equal 27, okay? So I'm going to put a few logarithmic expressions now up on the right-hand side, and we'll kind of go through exactly what they mean. So I've got, let's see, how we say this right here, this first one. This is log base 2 of 16 equals 4. Okay, log, we just call it log. We don't got to write out logarithms each time. So log base 2 of 16 equals 4. Okay, so we really have the same element of expression as we have with our logarithmic expression. Okay, so again, I've got a base here. That's what this kind of this little number here, we call that our base. And now I've got the end result that's kind of inside my log. And you might see log with like parentheses right here and here. Okay, that's indicating what my end result is. Okay, and then that is equal to 4. Okay, and 4 is my exponent or my power. So what this is saying is, if I have a base of 2, okay, what do I need to raise 2? Like what power do I need to raise 2 up to in order to get 16? So my end result here is 4, like we said earlier. I raise 2 to the 4th power and I get 16, okay? So looking down here, okay, think, what power must I raise 2 in order to get to 1? Okay, what power must I raise my base of 2 in order to get to 1? And anything raised to the 0 power gives you 1. Okay, so that's going to equal 0. Okay, so this is the power that we're thinking of, is our final answer for our logarithmic expressions or logarithmic equations, okay? Okay, and then down here, thinking the same thing. What power must I raise 3 to? Because 3 is my base. I've got a base of 3. Okay, what power do I have to raise that to? Question mark. In order to get 27. Well, we see over here that if I raise 3 to the 3rd power, we get 27. So that's going to be 3 for my final answer. Okay, so that is this concept of logarithms, and we'll take a look at how we can use the idea of logarithms as an inverse as well to solve exponential equations and rewrite exponential forms for exponential expressions. Okay, so let's take a look at a few examples now. Okay, we're going to write each equation in exponential form. Okay, so we have these logarithmic equations. We're going to write them in exponential form. So my first one, again, so I've got log base 4 of 16 equals 2. That's how we would read this out. Log base 4 of 16 equals 2. Okay, so I've got a base of 4. My end result here is 16, and then my power here is 2. Okay, so think of writing this in exponential form. Well, exponential form is going to be b raised to some power equals something, right? So b raised to the x equals y. Okay, so my base is b, my power is x, and y is my result. So I'm just using these same kind of terminology here and here, right? So now I can rewrite what I have here in this exponential form. So my base is 4, okay? My power is 2, right? And then my end result here is my 16, okay? So that's how we can rewrite something from logarithmic into exponential form. Let's take a look at this one over here. So I've got our base of 3, our result is 729, and our power is equal to 6, okay? So again, how would I say this? Log base 3 of 729 equals 6. Log base 3 of 729 equals 6, okay? So let's see, if I raise 3 to the 6th power, that gives me 729, so that's how we can rewrite that in exponential form. Okay, going from exponential to logarithmic form now. Okay, write each expression in logarithmic form. So I've got 4 raised to the 3rd power equals 64. So my base is 4, my exponent is 3, my result is 64. So now I've got this log base b of y is equal to x, okay, where x is my exponent, y is my result, b is my base, okay. Okay, so I'm just taking each term here and plugging it in. Okay, I take my 4, put it in here for my base, take my result, put it in here for my y, take my 3, put it in here for my x, and this is what I get for my equation in logarithmic form. Okay. Okay, same thing over here. I've got a base of 125, I've got an exponent of 1/3, and I have an end result of 5. Okay, so if I use this exact same kind of base generic formula here and just plug those in, then I'll have log of 125, log base 125 of 5 equals 1/3. Okay, so if I raise 125 to the 1/3 power, I get 5. That's what we're really looking at here. Okay, taking a look at evaluating logarithmic expressions now. Okay, we're going to evaluate each one of these. So each of these needs to equal something. So what this is saying here is 3 to what power equals 81. So I can think of this as having like question mark right here, right? This question mark is the same one right here. So 3 to what power equals 81? Okay, well 3 times 3 is 9, times 3 is 27, times 3 is 81. Awesome. So how many 3's do I have here? I've got 1, 2, 3, 4 3's. Okay, so if we raise 3 to the 4th power, we get 81. So log base 3 of 81 is equal to 4 for my final answer. Okay, taking a look at let's see, this next example here. Okay, so 2 raised to what, or sorry, 1/2 is my base, raised to what power equals 256? 1/2 raised to what power equals 256? That's what we're trying to solve here for this one. Okay, so again, I'm just going to say 1/2 times 1/2, that equals 1/4, times 1/2, 1/8, times 1/2, that's 1/16, times 1/2, that's 1/32, times 1/2, that's 1/64, times 1/2, that's 1/128, and then times 1/2, finally, I get to 1/256, which is what I have here, kind of, right? So let's see, how many times did I multiply that? I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 times that I multiplied 1/2 by itself to get this 1/256. Now this is 1/256, but over here I have 256. Okay, so how can I get this to flip? Well, if you remember in our exponents videos, or exponential expressions videos, if I have a base raised to a negative power, that's the same thing as 1/, that base raised to a positive power, okay? So b to the negative x is equal to 1/, b to the positive x, okay? So let's say if I were to raise 1/2 to the negative 8th power, okay, that's going to be equal to 1/1/2 to the positive 8th power. And this 1/2 to the positive 8th power, we just found out is this 1/256 here, okay? So if I have 1/256, I know that I can just take the reciprocal of the denominator here, and I get 256. Okay. So log base 1/2 of 256 is going to be equal to -8. All right, taking a look at our last examples here. Okay, we are writing equations for the inverses of the functions. Okay, so I have these functions, these are exponential functions. Okay, and I know I told you guys earlier that the inverse is going to be our log, right? Inverse is our log. So I know I'm going to have to use log in some way. Now, to find inverse of our functions, we go ahead and we switch the x and y. So I switch the x and y here. And then now I need to solve for y, right? Now I need to solve for y. So what I'm going to do is kind of strategically take the log of this base here. Okay, since this is my base, this 0.15, or sorry, this 0.5, I'm going to take the log with a base of 0.5 of each side. Okay, take the log of base 0.5 of each side. Okay, now when I do that, let's think about what I get on this side of my equation. Okay, this side of my equation, what does this term mean? Well, what this is saying is, let's see if it'll come up. Here we go. 1/2 raised to what power is equal to 1/2 raised to the y power? Well, in this case, this has to be, since I have the same base, and we saw this in a previous video, this is only true if this question mark that we have here is equal to y, right? This is only true if this question mark equals y. Okay, so this whole side of my equation actually reduces to just y. Okay, so I have effectively solved for y and thus have found my inverse. So the inverse of this equation here is going to be log base 0.5 of x is equal to y. Okay, now let's take a look at this expression here, or this equation rather. Okay, again, I'm starting off by switching my x and y here. Okay, that's what you see here. All right, and then again, I'm going to take the log of whatever this base is. Okay, so log base 10 of both sides of my equation. So if I take the log of my left-hand side of my equation, I got to do that to the right-hand side of my equation. Okay, and we'll get into kind of some other properties in future videos, but just know that we're strategically doing that because now when I take a look at this expression right here, again, this is saying 10 raised to what power equals y minus 1. Well, this is only true if this question mark here that we don't know equals y minus 1, right? Okay, so this whole expression can be reduced to just y minus 1. So now I have log base 10 of x equals y minus 1. Okay, and then I can go ahead and add 1 to each side, and I get log base 10 of x plus 1 is equal to y. Okay, that's my inverse. Now be careful here. Okay, the x is part of this logarithmic term right here. Okay, this plus 1 is not included in this parentheses. Okay, so this is not the same, not equal to, say, log base 10 of x plus 1. Okay, so be careful we're not adding that 1 into this logarithmic term. We're just adding it off to the side. Okay, so we do not want to, when we add, do that. We want to keep those separate since they are separate terms. Okay. All right, guys, that's all for this video lesson. Good luck with your practice.